So today we are going to look at logarithmic inverses and inequalities here. So one of the things that we're going to be expected to do is be able to find an inverse for an exponential or a log function, which is very much like solving the equations. And log inverses work just like any other inverse. We switch our x and y's and solve for the new y. So, if we get an equation like this, h of x equals 3 to the x plus 1 minus 2, k of x equals h inverse of x. For what values of x does k of x equal 1? So, you've got a few options on how to do this problem. I'm going to do it sort of, I'm going to call it like the long way first. I think it's the way that, like, if I was a new student learning this, it's the way I would go about it, but it takes a little bit longer, and then I'll also show you like a shortcut that you could have used on this as well. So if you get this, you could find the inverse, right? We could find the inverse. So if we find the inverse, this is like my y, so I'm going to switch x's and y's. I got x equals 3 to the y plus 1 minus 2. And I need to solve for my new y. So if I'm solving for that new y, Hank, what would I do first? Yep, that's it. You got to get rid of that 2 before you can mess with anything else. So you got x plus 2 equals 3 to the y plus 1. Okay. So, Alyssa, what do you think we should do next? What have we got to get rid of? We need to get to the exponent, so we need to get rid of that 3. Like the base has to go. How would we get rid of that 3? What do you think, Connor? Log base 3. So to get rid of a base of an exponent, that 3 right there that we're needing to get rid of, we're going to use log base 3, and it'll get rid of it. So we would also be doing log base 3 of the left side as well. So now we've got log base 3 of x plus 2 equals, we just got y plus 1 over here. And so, Autumn, what would the last thing be? Trying to get that y right there by itself. Minus 1. So we're going to subtract 1. You cannot subtract 1 on the inside of the log function. It's just going to be out to the side. So you're going to get h inverse of x equals log base 3 of x plus 2 minus 1. And I find it a little complicated, but AP uses this wording sometimes. They're telling you k of x is the inverse of h, so we could also just call this k of x, right? Like they're k of x and h inverse of x are the same. So if it wants me to find where k of x equals 1, so where the inverse equals 1, what should I do? 1 in the y spot. So now I got 1 equals log base 3 of x plus 2 minus 1. So now I need to solve for that x, right? Michaela, what would I do first? Add the 1. Because it's on the outside of that log, so you want to get rid of it first, and then you'll have to get rid of the log. And Michaela, what would we do to get rid of that log? Perfect. And that will get rid of our log. So we got 3 squared, which is 9, equals x plus 2. We're almost there. Last step, Michaela. Very good. 7 equals x. And that is what they're looking for there. I like working through that way because that is helpful to us if they like ask us any part of that. But there is a shortcut that we could have used because what we have here, they gave us k of x equals 1. K of x is h inverse, right? This is h inverse of x. So that means on my table for h inverse of x, I'm looking where the y coordinate is 1, right? X coordinate is, I don't know, right? If I want to know what that value is, if I think about the table for x, h of x, like the original function, what happens to that point? It'll be flipped, right? Which means the x coordinate is 1 and the y coordinate we do not know, right? So that question mark is what we're looking for. Now, if I know that x equals 1, how do I find h of x at that point? I just plug it in, right? So I would just do h of 1, which is 3 to the 1 plus 1 minus 2, which is 3 squared minus 2, which is 9 minus 2, which is 7. There's my answer that goes with it. So because this is a y coordinate on the inverse, it's an x coordinate on the original, and you don't even have to find the inverse to do that. Okay, questions about that? So this would be a great way to solve it if you solve this question, because it's going to save you time here. But totally solvable the other way as well.
Does that work for every single one of these problems? Like that are similar to that, or is it just like a one-time?
We're going to have, it would work, anything with an equal sign like that, it would work. And it would have to give you the y coordinate here. If they asked you for like k of -2 or something like it was, they gave you the x coordinate, then it wouldn't really work. So now you could like make that -2 the y on the original if you want, but as long as you got an equal sign, you should be pretty good. If you have a less than or equal to -31, that makes this a little trickier to deal with, although we could still look at it this way, right? So in this case, if I want, well, actually, this one's not an inverse problem anyway. So in this case, I want to know where this function is less than or equal to -31. Okay, so let's just look at it. This one doesn't have a calculator next to it, but let's look at it on Desmos, because sometimes seeing what's happening here. If I want to solve this one on Desmos, I would just need to graph it. K of x equals 1 minus 4 times 2 to the x minus 3. So I've got this. And then I am looking for k of x is less than or equal to -31. You don't really want, like you can't, I don't think you can, it gives you the answer, but it's a little bit different. We're looking for like where this is below -31. So if I type in y equals -31, it puts me a line right here, and I want to know where this graph is below that value. So you can see right here that that happens at 6. Negative 31 is like where we cross, so it would be everything bigger than 6 that gets plugged in will be below that. But let's think about what we would have to do if we didn't have a calculator for this. Oh, you're right. It would count 6. So 6 and beyond. So we would include it. You're right. For this, if we have to do this without a calculator, you have to be careful with the inequality sign because sometimes things don't work out quite right with the inequality sign. I'm going to work it with the inequality sign and then we'll see if it gives us the right answer or not. Sometimes you might need to test points for this. So we got 1 minus 4 times 2 to the x minus 3 is less than or equal to negative 31. So solving inequalities is almost the same as solving an equation, except what do I have to do differently? There's one thing that if it happens, I got to do something different. If I multiply or divide by negative, got to flip the sign, right? So first thing I would do here is I would subtract 1. So I got negative 4 times 2 to the x minus 3 is less than or equal to negative 32. And right here, I'm going to divide by negative 4. And so when I do that, I'm dividing by a negative, so I've got to flip the inequality sign, greater than or equal to 8. And so I then got to get rid of that 2. How do I get rid of 2 whenever it's a base? Not square root, log base 2. Because it's not an x squared, that we would square root. But this is the base you're trying to get rid of. So you're going to do log base 2 right here. And log base 2. So I got x minus 3 is greater than or equal to, let's imagine this is a calculator inactive problem because it can be done calculator inactive. What is log base 2 of 8? It's 3. How'd you get that? 2 to the third is 8. So log base 2 of 8 is log base 2 of 2 to the third, and the logs and the 2's cancel, and you just get 3. So this is x minus 3 is greater than or equal to 3. And then we just have to add our 3 to both sides. So x is greater than or equal to 6. Now, I would suggest on this, because sometimes some weird things can happen with this, I would suggest picking a number and plugging it in to check to see if that works. So I've got greater than or equal to 6, so I'm going to pick a number bigger than 6. It doesn't really matter. I'd go 7 probably because that'll be the easiest thing to use. If I do 1 minus 4 times 2 to the 7 minus 3, I get 1 minus 4 times 2 to the 4th. You got to do your exponents first before you multiply. So it's 1 minus 4 times 16. And that's 1 minus, so that'll be 40 and 24, 64, which is negative 63. That's definitely less than negative 31. It's a good idea to like pick a point and plug it in at the end of this to make sure that it really is less than or equal to negative 31, because it's very easy to forget to flip your sign or do something weird that causes you to like get the opposite answer for this.
Wait, is it 7? Is that like just because it's...
I just picked 7 because it's a number bigger than 6, but any number bigger than 6 would be fine to plug in to check, to make sure. It doesn't guarantee that you're right, but let's say that you messed up and you forgot to flip your inequality sign and you got x is less than or equal to 6. So if you plugged in 5 or 4 or 2 or 1, you would not get a number that's less than 31 or negative 31. So it's a reassurance that you're right. Questions? Log base 2 of 2 is going to cancel right there. So what we're doing is because we can on this, we're taking that 8 and rewriting it with a base of 2, and that way it will cancel out. So like if I had something like log base 3 of like log base 3 of 27. Let's do 81. Right? So like that one's one that can be done without a calculator. If it's calculator active, just use your calculator, that's fine. But you might find yourself stuck on a calculator inactive problem where you've got to do something like this. So like what I want to do is I want to do log base 3 of 3 to a power right here. So you're thinking 3 to what power would give me 81, and it would be 4 right here. So then the log base 3 and 3 would cancel, and you'd get, oh, I'm sorry, I'm wrong. You'd get 4 as your answer for that. If they have put it on the calculator inactive section, something like that should work. Like if they gave you log base 3 of 18, that won't work. Like that, you're going to have a calculator to do that. So they should only give you this if you have ones that you can actually work out. If it is free response, it depends on how they word the question. I think you're probably more likely to see this one on the calculator on a multiple choice question. So they will simplify it. So you'll have to know.
You get the same thing if you just said like KX equals A31, or like just have equals all the time.
The only thing is you will not know whether or not it's greater than or equal to or less than or equal to. So you would need to test your points for that. So you would need to like try a number big above or below and see which one makes it work. But yeah, you could do it with equal sign and then just test at the end. Okay, so next we're going to look at logarithmic inequalities. We can solve log inequalities involving exponentials and logarithms in the same way, except for it's much simpler. We're working with exponential and logarithmic equations, believe it or not. The first thing you're going to do is determine the domain of any log expressions in the inequality. All right, so then you will combine logarithms that can be combined. You're going to use exponents to rewrite it and solve the remaining inequality. A sign chart may be necessary. So in this case, much like our equations, you cannot have negatives inside of the log, right? Or 0, right? So what you have to do at the beginning is you have to think about the domain of these two things. I'm going to start with the domain of x plus 3 because it is easier. X plus 3 has to be greater than 0. So x has to be greater than negative 3. So whatever answers I get have to be greater than negative 3, or they're going to be extraneous solutions, right? So I have to think about that. I also have to think about x squared minus 4x plus 7 has to be greater than 0. Now this is tougher because I can't just like solve that super easily, right? What I have to do is I've got to factor it. So I will have x, oh no, oh gosh, oh gosh. This is a quadratic formula. Oh, let me look at the key on this one to see if I want to proceed with 15 minutes left to go.
Could you do this without like quadratic formula or no?
Not this. Oh, that's the wrong thing. I won't. Oh, I didn't even put the. I don't even have the key downloaded. Ugh. That one's so bad. The next one's the same. Well, no, the next. All right, we may not do the next one. All right, so I don't know if they're all going to end up. They could end up much easier than this if they factor. This one doesn't factor, right? So, so since this does not factor, our only options are completing the square, which I imagine you may have forgotten, or quadratic formula, which we should be a little better with. So quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And your a is 1, your b is negative 4, your c is 7. So you're going to have x equals positive 4 plus or minus square root. Technically, it's a negative 4 squared, but when you square negative 4, you get the same, you get a positive number. I usually just leave it off because sometimes you'll type it into the calculator wrong if you're using the calculator. And we got minus 4 times 1 times 7. Oh gosh. What's about to happen? Maybe. Okay. All right. So I think what's happening here. Okay. This actually might be okay. We might be okay. This might be better than getting a real answer. Actually, it's not better than a factoring. It would have been easier if I factored it, but we're going to get 16 minus 28 right here on that part. 16 minus 28, which is going to give us negative 12 all over 2. That's going to be imaginary because you got a negative because you got a negative underneath the square root. So what that tells me is that this is either always positive or always negative. It doesn't have any real zeros. Okay? So it could be any number that you plug in, but 0 is the easiest number to plug in. If you plug in 0, what do you get? Positive 7, right? This is always positive. So this part is always true. Right here, it's always positive in this case. So since that is always positive, we don't have any restrictions on its domain here. So if you get imaginary roots, it is either always positive or always negative for a quadratic there. So I know my answers have to be greater than negative 3, but that doesn't mean that's the answer. I'm looking for where log of x squared minus 4x plus 7 minus log of x plus 3 is greater than 0. And so I'm going to solve this like we've been solving it. I'm going to have log of x squared minus 4x plus 7 over x plus 3 is greater than 0. What do I have to do now? 10 to the power, because this log doesn't have a base, so its base is 10. So I do 10 to the power on both sides. That gives me x squared minus 4x plus 7 over x plus 3 is greater than, what is 10 to the 0 power? 1 here. Okay. Gosh, really. He said this is supposed to be easier. And I feel like I'm doing something wrong. Let me go look at it. Let me go to my folder with this stuff in it. In my Google Drive. Because I feel like I might be messing something up here.
Why do we need that first step about the domain?
Sometimes it conflicts with your answer. So if we get like our answer is x is less than 7, like less than 7 includes -4 and -5 and -6. So yeah, right. So you have to like further restrict your answer on those. Let me look real quick here though to make sure I'm not. Oh, that's not my pass water stuff. I need to go here. I need to go here. 2 notes. 213 notes 2 key. Let's see what we got here. Okay. That's the first part. I need 1. Did he redo these? Good gracious. He redid it. Okay, same question though. Okay, alright. Okay, good. I was going to do something more complicated, so I'm glad I looked at that. Okay, so it would have still worked, but it would have been more confusing. So whenever I have this here, I could like subtract the 1 and have like a whole rational function stuff, but to do this here, what I want to do is multiply by x plus 3 to get that out of the bottom, because we can't solve for things like that when they're in the bottom. So I've got x squared minus 4x plus 7 is greater than x plus 3. And we might get confused on what to do here because we got so many things to remember. But if you see a quadratic with an inequality or not an inequality, in general, move everything to one side. You want to move everything to one side, try to factor if not quadratic formula is there. So if I subtract this x and subtract that 3, I get x squared minus 5x plus 4 is greater than 0. And so this will factor. It is x minus 4 and x minus 1. Now, you do have to do a tiny little sign line for this, because you are going to get x equals 4 and x equals 1 as your like points, but we have to look at like entire regions for this, right? So we've already done this several times, so this is like going back to something that we've done before. I'm going to put 1 and 4 on my line, and then I like to make the chart where I've got x minus 4, x minus 1, and my answer. And so on that top line, I would get negative, negative, positive. On the next line, I would get negative, positive, positive. It's going to give me positive, negative, positive. But here is where that first part that I was doing comes in. So my answers are greater than 0, so it's my positives, right? So it's this section and this section. But at the very beginning, what did we say? We said x has to be greater than -3, right? Because anything less than -3 is going to mess up our equation. So I'm going to do this. I'm going to add like -3 right here on my line, and everything down here you can't have. It's an x. You can't have it down here. So when I start to give my answer for this, I don't want to go below -3. I want to say -3. I'm going to use a parentheses with that. Parentheses means I am not including that -3, because if I have a -3, I'm going to get a 0, and I can't take a log of a 0. Up to 1. Actually, you don't even have to think about it that much, because it's a greater than, so everything's parentheses. And then 4 to infinity.
Even the points that you get, like x equals 4,
Yeah, those are, because this question was greater than 0, that's what you'll have for this here. At the very beginning, we looked at the domains for these, and you can't have a number lower than 3, or negative 3 in here, or it's going to give you a negative inside of the log, which is going to be extraneous solution. So you have to throw that back in at the end for that. The imaginary lets you know it's always positive or always negative. So it doesn't actually give you like a part you need to restrict because it's not a real number on the real number line, but it lets you know it's always positive or always negative. We're not going to do 4, but like if I look at that one, will x squared plus x, let me show you like a quicker way. I am having to do g of x less than h of x. And so when I'm doing domains right here at the very beginning, I know that x plus 4 has to be greater than 0. So x has to be greater than negative 4. That part is easy. Will x squared plus x minus 5 factor? It will not factor. So if it won't factor, I'm thinking there's a decent chance that it is going to possibly be imaginary. So one thing you could do before you even try is you could plug in a number. In this case, I get 0 squared plus 0 minus 5. That'd be negative 5. This one's going to be, it's going to have some negatives. If it's always negative, there's just no solution to this problem. So there's a decent chance that's not the case. This is one where you would have to do quadratic formula. But if, like, let's say that was a plus 5 right there, there's a pretty decent chance that you're going to get like always positive and no restrictions on that. So that can help you a little bit there. All right, so we didn't get to